This is Algebra 2 at Trig 9.6a. We're talking about standard normal distribution. Before we get into that, we'll do a little warm-up. Today's warm-up is going to deal with trying to find a missing test score. So go ahead, pause the video, solve for the fourth test. What does it need to be for you to have a total average of 80%? Here we have an 80% test score, a 72% test score, a 77, and an extra test score. So that would be all our test scores. Divided by 4, because there would be 4 test scores. That would give us our average of 80%. That's what we want. We want an average of 80. These are the current test scores, and we're looking at having a fourth test. So we add these numbers up. 140, this would be 220, plus the extra 9, so that was 229 plus x divided by 4 equals 80. Cross multiply, and we get 229 plus x equals 320. 8 times 4 is 32, and the extra 0. Subtract the 229, and x is going to be 91% on next test. So that's what you would need. So now you want to look at what you did. What are some different strategies that you had? Okay, now we're going to lead into normal distribution. What is normal distribution? Well, it is a statistic. This comes up in statistics, and it's a probability that the distribution modeled by a bell curve that is symmetrical among the mean. So here's an example of having a mean. That's the x-bar. We've seen that before. And it is symmetrical. As data increases, the number of items are decreasing. Like perhaps, let's just say height. The average person, there's a whole bunch of people at the average height. As you consider taller people, there are less and less numbers of taller people. And there would be less and less numbers of shorter people compared to the average. I'm not convinced that height is completely normally distributed, but in some of our story problems we might say so. Okay, a normal distribution with a mean of x bar and a standard deviation has 3 properties, or these properties. The total area underneath the curve is considered 1. When we look at the percentages, this says the percent of the area that lies within 1 standard deviation. Come on in here and take a look at what 1 standard deviation is. Here's your mean, and you're going to add plus 1 sigma and x bar minus 1. So that's within 1 standard deviation. So if you look at your chart here, it says that 68% of the data is within 1 standard deviation of the mean. That is not going to change. That will stay consistent through the whole lesson. Every problem that we do normal curve, that's what makes it a normal curve, that within 1 standard deviation is 68% of the data. What percent of the data is within 2 standard deviations? There's your average, your mean. 1 standard deviation, 2 standard deviations goes way out here. 1 standard deviation, 2 standard deviations above the mean goes way out here. And you'll see that that is 95%. All the data should land, 95% of all the data should land within 2 standard deviations if it's truly normally distributed. And then 99.7% of the data will land within 3 standard deviations. Now, if you know those numbers, that's really all you need to know. If you know those numbers, we can break each one of these categories, each one of these columns into a percentage. If the middle was 68 within 1 standard deviation, then the 68 divided into 2 equal parts is going to be 34 for each part. We know that within 2 standard deviations is 95. We're not going to count the 68. Now that's going to be the leftover 2 columns, 2 areas. And we divide that in half, so it's 13.5 for each of them. 13.5% of the data is here on the left, 13.5% of the data is here on the right. If we take 99.7 and subtract out the 95 and cut that into 2 equal pieces, then we're going to have 2.3% of the data. 3.5 is right here. And then the leftover amount, if you had 100% and you weren't looking at the 99.7 and you divided that into 2 equal amounts, that's where the 0.15 comes from. So if you can't memorize this, you can calculate this. You can determine that by doing things that we just did here. You can always look back at your chart. These numbers you need to know. These numbers you can figure out from that. There's 50% on one side of the mean, and there's 50% on the other side of the mean. So let's come on down and try to use this. A normal distribution, okay, whatever the situation is, whatever the storyline is, has a mean x, so x bar, and a standard deviation of sigma. What's the probability that we're going to select an x value that is less than the average plus 3 standard deviations? So what does that mean? There's the average plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations. So we're looking right here and everything less than that. And we're not stopping. We're doing all the data. It continually goes to the left. But it starts right there. What are we leaving out? We almost have 100% fully covered. What are we leaving out? Right there is our 0.15%. So 100 minus the 0.15% would be 99.85. Now notice that this is talking about P for probability. So our best answer should be a number between 1 and 0. So 0.9985. If it's asking for the probability of x being that value, we want to give our answer as a value between 0 and 1. Over here, try to make sense of this. What is this telling you? Can you read that? You have an x value. You want it to be greater than 2 standard deviations below the mean. So we come here. Here's 1 standard deviation below, 2 standard deviations below. We want to be greater than that all the way up to 1 standard deviation above the mean. So we'd be in this shaded region. what percentage of the data lies within that? Well, look what they've done. They've done the numbers for us. 13.5 plus 34 plus 34, that's 68, 78, 79, 80, 81 and a half. 81 and a half. So we could say 815. 0.815 would be the probability that a value was chosen that landed within this range. So you go ahead and try this problem. You'll probably want to draw your own normal curve. In the middle, you're going to have X bar. Down one side, you're going to have one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean, and then you have 1, 2, and 3 standard deviations below the mean. You want to know the probability, and look at your inequality. It says greater than 2 standard deviations above the mean. This we learned was 34. This we learned was 13.5. We're not using either one of those. So this is our 2.35, and this is our 0.15. So that's going to be, if we added those together, that's going to be 2.5. And we divide that by 100 to turn it into a decimal. So the probability would be 0.025. And then this one has a lower bound and an upper bound. So drawing in your own standard curve, got your average in the middle. 1 standard deviation, 2 standard deviations, 3 standard deviations below the mean, 1 above, 2 above, 3 above. You want to go from 1 below, because there's not a number in front of sigma, 1 below, that was 1 above, 2 above, 3 above. So if you want to see your lines in here, be just like that. This is 34. This is 13.5. This is 2.35. This here is 34. So we'd have 34 plus 34, that's 68, plus 13.5. That's 81 and a half, plus 2.35. So we said 81, 82, 83.85. So that should become 0.8385. Questions about that? Okay, here's a different type. Math scores from 2004 SAT exam are normally distributed with an average of 518. So we're going to put 518 in the middle. That's the average. And a standard deviation of 114. So you have your 518, and you're going to add 114. So those are your 3 numbers that are your standard deviations above the mean. 632 is 114 up. 746 is 114 above that. And 860 is 114 up above that. get back down to the mean, and your next three standard deviations are going to be those. 404, 290, and 176. Remember, we're going to have 34% of the data in there, 13.5% of the data. This little bit in here is going to be 2.35, and this one is going to be 0.15. This is 34, 13.15, 2.35, and 0.15. Those are all the numbers we talked about before. You want to get used to using those numbers. They're repetitive. You can check your data, see if it's right. You know that this middle section is 68. The sum of two standard deviations is going to be 95. The sum of three standard deviations is going to be 99.7. But you can always check it. Okay, what's percent? This time they're asking for a percent, so we can give our answers as a percent, not a probability. What's the percent of the test takers have scores between these two? So from 518 up to 746, that's going to be 34 plus 13.5. That's 47.5, and that's a percent. They're asking for a percent, so it's okay to use percent. What percent of the data takers have scores less than 404? Do you understand what less than means? Some people get confused with the less than part. You don't have to be worried about, well, does it include it or does it not include it? It's just your percentage values. So you're at 404, and if you go less than that, you're going to the left from 404. So that includes 13.5, 2.35, and 0.15. So this together makes 2.5 plus your 13.5, that makes 16%. 16% of the data would be less than 404. What percent of the data test takers have scores between 404 and 632? Well, 404 and 632, it looks to be one standard deviation below up to one standard deviation above. That's, of course, our 34 and 34. That's our 68%. We can't get much more creative than that. That's all we can do with these numbers. And then this one doesn't seem to be written right. About what percent of the test takers have scores, get rid of the word between, have scores greater than 746. 746 and greater than that. That's going to be 2.35 plus 0.15. That gives us 2.5. And that's a percent. And then a little bit more of the same. A typical night's sleep for a college student is normally distributed. Normally distributed is telling you it's following this bell curve. Okay? That's what allows us to use this data, because it is normally distributed. That's why they tell you that. With a mean of 7 hours, so the 7 goes in the middle. With a standard deviation of 1.7. So we take our 7 and add 1.7, Those would be our 3 standard deviations. 8.7, 10.4, and 12.1. Then I can take it back down, minus 1.7. Okay, now we're back to 7. That's our average. So 1.7 below that, and below that. There's our standard deviations below the mean. So, answering the questions about what percentage of the college students sleeps between, well, here, let's go back in here. It'll be best if we fill in our data values. See if you can fill those in without looking. Can you fill those in without looking up and down, and up and down so many times? So, same type of question. Just adding up the values. 5.3 seems to be 1 standard deviation down. 8.7 seems to be 1 standard deviation above. That's, of course, 68%. Okay, here's a good one. What is the interval of sleep for 95% of the students? 95% I know is going to be 2 standard deviations from the mean. So my x value is going to be, my value is going to be greater than or equal to 3.6, but less than or equal to 10.4. That would be our interval. Those would be in hours, because that's what 3.6 stands for, is hours. I was trying to decide, do I need to put x bar minus 2 standard deviations, or do I actually use a number? And because it's in hours, we're going to actually use a number. Okay, last ones. You should try these on your own. So pause the video and start these up on your own. We have an average of 172 with a standard deviation of 14. So 186, 200, 214. That's going to be 158, 144, and 130. Try to fill in your own percentage values, and then you can kind of grade it and test it to see how you did. More times you do it, the better off you're going to be. $158, that's going to be, again, 34 plus 34. Readings higher than 200 are considered undesirable. What's the percentage of readings that are undesirable? There they are.